Hi everyone, welcome back to the channel. In this tutorial, you will learn how to download precipitation data for a specified region or a point location using a platform called Climate Engine. And the specific type or the dataset that we are going to draw this data from is, as you read in the title of this video, is called CHIRPS. Now, if you've never come across the term CHIRPS, CHIRPS basically stands for Climate Hazards Group's InfraRed Precipitation with Station Data. It's a high-resolution global precipitation dataset that combines satellite imagery with in-situ station data to produce accurate and detailed precipitation estimates. And CHIRPS was originally developed by the Climate Hazards Group at the University of California in Santa Barbara. So there's going to be two main parts in this tutorial. And in the first part, I'm going to show you how to visualize these precipitation data in a spatial context, and that would involve using this kind of an interactive map to specify the region for which you're going to download the data, and then actually getting it over to a GIS software like QGIS in the form of a raster like this, which opens up a whole new bunch of possibilities for us to go forward with from there onwards. And in the second part of the tutorial, I'm going to still download a precipitation dataset, but now being focused a bit more on the actual data itself. For example, how to obtain a time series dataset for a specified period with a daily resolution like this, which we can then import into a spreadsheet processing software like Excel and perform the subsequent analysis that we might be interested in doing, potentially. So with that introduction, let's get right into the tutorial. And to get started, we are going to head over to this portal which is called climateengine.org. You can simply enter that in your browser like this, climateengine.org, and that should take you into this landing page. And after that, I'm going to click right over here on this launch app button, and that's going to basically launch the app or the portal from which we would be able to basically make the specifications regarding the area for which we would like to download the data. And as you can see, in order to access the portal, you're going to have to create an account with the climateengine.org, which is going to be an extremely simple task. So I'm not going to guide you through that. So I'm just going to go ahead and input my email and password right over here. But in your case, if you have never used this portal, you're going to have to click right over here to sign up for free. Just fill up the form and you should be able to log in almost immediately. And when you get into the portal for the first time, you're going to be greeted with this sort of a page which offers you the capability of going through some guided tours and some video tours to make yourself a bit more comfortable when it comes to using this portal. But I'm just going to exit out from this because by the end of this tutorial, you will know exactly what to do to download such a dataset. So to give you a bit of an introduction to this layout, you can see right over here, we have two tabs. The first one is called Make Map and the other one is called Make Graph. So as I told you guys at the beginning of this tutorial that I'm going to split my video into two different parts. And in the first part, I'm going to show you how to create a map or how to sort of provide a spatial context to the variable that we are going to download, which is precipitation. And in the second part, we are going to actually dive into the actual data itself. So that's how we are going to actually make the distinction between the two. And for the time being, I'm just going to focus on this make map part because with this option, what I'm going to do is I'm going to basically download a dataset that covers a specified spatial extent. And I'm going to save that in the form of a raster. So let's see how to do that. So when it comes to the selections, you have to select a couple of things to make sure that you narrow down your search according to what you're looking for. And when it comes to the type, we can retain that to be climate and hydrology. And quite important, the dataset that we are going to be interested in for this particular tutorial is going to be this one right over here. So you can see that we have three different options when it comes to CHIRPS. And at the end of this label, you can see right over here that this has a daily time resolution and this one comes with a pentat or a 5-day time resolution. So what I'm interested in is this daily data. So I'm going to select this one right over here. And from here, you can see the variable that we're interested in is precipitation. Units, I'm going to set it to be millimeters. And the statistic, if you try to expand it, you would see that we basically have just one option, which is total. And if you just put your mouse pointer right over here, it'll actually give you what's actually meant by this statistic. For example, when it comes to specifying the date range, which we are going to do right over here, if I were to specify a date range corresponding to one entire year, that is maybe starting from 1st of January until the 31st of December of the same year, And if I were to select total right over here, then what I'm going to get as my output, it's going to be the total precipitation which correspond to that particular year. Because it's going to basically add up the precipitation which corresponds to all 365 days of the year. And it's just going to give me one raster output. And as you can see over here, there are some other statistics as well, mean, median, minimum, maximum. But for some reason, none of them actually appear over here. So only the option to calculate the total is available at this particular moment. I'm not really sure whether in the future they might consider adding the other statistics as well. And when it comes to the calculation, we're going to stick with the values. And quite important right over here, the time period for which you would like to obtain your data. So as the very first example, what I'm going to do is I'm just going to download a dataset which corresponds to just one single day. So in order to do that, I'm going to head over to custom date range and just going to pick a random date. Let's make the starting date to be 8th of August 2023 and the end date to be 8th as well. And now what I'm going to do is I'm going to specify the region or my area of interest for which I would really like to generate this data. Now before doing that, I'm going to basically hold down the control key and I'm going to use the scroll wheel of my mouse to sort of zoom out. And the reason why I'm doing this is to sort of get a zoomed out view like this, and when I hit this get map layer button, it's just going to generate the data for this particular specified date range. And it's going to show you the region for which the data is available. So you can see there is actually a clear cutoff point. So above this line, you wouldn't really be able to get any data. And again, for demonstration purposes, I'm just going to randomly zoom into, let's just zoom into Taiwan like this. And what I'm going to do is I'm just going to try to download a raster data set, which basically covers the entire extent of this main island. And how would you exactly specify that extent? You could basically head over to download right over here, and from here you can select rectangular region. And after that, what you can do is you can basically shift this rectangle around and just grip it from these corners and adjust it until you get or until you cover the full extent of the island like this. And after that, head back to this download option again, and you would see that automatically these coordinates would get updated with the corresponding latitude and longitude coordinate information. And I'm going to download the data at its native resolution. And let's just say that we would like to autofill the file name. Well, it's just completely up to you. If you would like to type in a file name for this, you could do that as well, but I'm just going to let the program decide what sort of file name it's going to use for this. And after that, you can just click download map layer. It's going to provide you with a link, which is this one right over here. You can simply click on this link and it'll basically route you to this link, and the download should begin immediately. So let's go ahead and click on this link and navigate to your working folder. After that, you can just click save. And if you happen to open up the folder, you will see a zip file like this. I'm going to extract this into the same location. And as you can see, the file that was inside this zipped folder was a TIFF file, as you can see right over here, which means we would be able to view this file using a GIS software like QGIS. So let's just go ahead and delete this file. And I'm just going to open up QGIS, and I'm trying to see whether I can open this file using QGIS or not. Alright, here's my QGIS workspace, and I have already navigated into my working folder, and you can see that raster right over here. I'm just going to drag it and drop it onto my workspace like this. And sure enough, you might be able to see how the precipitation basically varies across my downloaded region. However, it might not be that apparent because the color scale that's being used right over here is basically varying from black to white. So I'm just trying to see by altering this color scale whether I would be able to get a bit of a better representation of the spread of the different colors. So for that, I'm just going to click over here and head over to symbology. From here, select single band pseudo color. You can basically pick a color ramp that you like from here. I'm just going to stick with this color ramp that I get by default and see how it looks. So you can see that the highest precipitation values would be represented by this blue color and the lowest accordingly by this red color. So click apply and click OK. And yes, according to this, you can see that most of the areas have not really gotten any rainfall. However, there are some variations right around this region in rainfall. So as you can see, the sharpest blue colors, as I told you guys, indicate the locations which receive the highest rainfall. And if you would like to sort of give a spatial context to this dataset, I think it would be quite handy if we manage to sort of place a base map below this. So I'm going to use one of my base maps. Let's go with the OpenStreetMap. And now if I go to properties and maybe decrease the opacity just a little bit. Yeah, so you can start seeing that most of these areas have not really received any rainfall, but right around this region, it has actually received about 70 millimeters in rainfall within this given day at this particular point. And something quite obvious is that the distribution of the precipitation is not extremely smooth. That's because of the resolution of this raster. So if you're curious about the resolution of this raster, what you can do is you can basically zoom into one of these pixels and you can head over to this measure line tool. After that, if you start basically measuring or drawing a straight line from one corner to another like this, you can start seeing roughly it comes up to about 5.1 kilometers. So you can consider that to be the resolution of this CHIRPS dataset. It's roughly about 5 kilometers, we could say. And if I do the same thing again with another pixel, it's going to be exactly the same. It's going to be about, roughly about 5.1 kilometers. So that's the resolution that you're going to get. That's the spatial resolution that you're going to get with this CHIRPS dataset. Now, one more interesting thing is that because of this spatial resolution, now one might think that it might be a relatively large spatial resolution, which means that if I were to just zoom into one pixel, if you happen to just pick the precipitation at a point location somewhere right over here, or somewhere right over here, or somewhere in the middle, or somewhere around this corner, you're just going to get exactly the same value because you're going to be still within the perimeter of this particular pixel. And the value of that particular pixel, again, you can check, especially when you're using GIS software like QGIS, by taking this tool, this Identify Features tool, and right click right over here and select the corresponding layer, and that's going to give you the exact precipitation value. That's 70.9 millimeters, as opposed to the precipitation of an area like this, where it's going to be about 25.6 millimeters. Alright guys, so I think you guys got the basic idea when it comes to how we can basically explore the precipitation data with a spatial context. And I'm going to do the same exact thing again, but using a different time period, just so that the concept of using the statistic of total would be much more clear to you guys. So let's head back to the portal again, and this time I'm going to pick my starting date to be the 1st of January of year 2022. Well, it's just a completely random selection. And I'm going to select my end date to be 31st of December of the same year. Which means now what I'm going to do is I'm going to download the data for this entire time period. And just because I have selected my statistic over here to be total, what I'm going to get is basically the total rainfall corresponding to this particular date range. So let's just go ahead and see how that looks now. We're not going to make any changes to our selection right over here. So I'm going to stick with this rectangular selection. Head over to download and I'm going to again leave this to autofill. And after that, just click download map layer. Click on the go to link. Yeah, and as you can see right over here from the file name, it specifies that the date range is 1st of January to the 31st of December. Click on save. And now we can head back to our working folder and extract this newly downloaded file as well. After that, I'm just going to get rid of that original file. After that, open up QGIS again. And from here, you can see that newly downloaded file right over here. Just drag it and drop it over the working space. So as you can see, the distribution of rainfall is much more apparent compared to that daily record. So if you start paying attention to these values right over here, so you can see that the record which corresponds to just one single pixel, if I'm not mistaken, happened to have a maximum rainfall of 70 millimeters, and it's just values in between 0 and 70.9 millimeters. But in this case, you can see that the maximum is going to be 3,435 millimeters. So this particular point or this particular region definitely can be considered to be the area that received the highest rainfall in this particular year, which is year 2022. And as I told you guys, because we selected the statistic to be total, what we get right over here from this raster is basically the total precipitation or the total rainfall that fell over Taiwan during this year. So let's just go ahead and change the color ramp to be something a bit more attractive. Go to single pan pseudo color. After that, well, I'm just going to stick with this, the same color ramp. Click apply and OK. And from here, you can clearly see the pockets where the rainfall records happen to be the highest. One is right over here and the other one is right over here. And there's a small area right over here as well, which apparently has received a relatively high rainfall. If you happen to pick this tool right over here, this identify features tool, you could directly go ahead and inspect what each of these pixel values actually mean. Just right click and make sure you select the correct raster. In this case, we are referring to this first one right over here. And you can see that the maximum rainfall is 3,435 millimeters in 1 year. And you can see that this area right over here doesn't seem to get that much rainfall, well, relatively. And if I were to just right click and pick the correct raster, you can see that it's about 924.6 millimeters. And since this is a TIFF file, you could do all sorts of things that you would like to do with a raster. If you have a shapefile of a specific area, you can basically cut out an area that you're interested in. Or if you would like to get some specific zonal statistics based on the distribution of these pixels, you could do stuff like that as well. So it's basically up to you, but I hope that the process of selecting and downloading a specific dataset after properly giving the instructions to Climate Engine is quite clear to you guys. So that's the spatial part. And now let's directly go into the time series data itself in the second part of this tutorial. So we are back on the climateengine.org portal. And this time I'm going to jump to this Make Graph tab. And we are going to get started with the appropriate selection now under this tab. And when it comes to the time series calculation, I'm going to stick with native time series and one variable analysis. Well, you could deal with two variables at the same time as well. For example, a precipitation dataset and a temperature dataset. But once you understand how to do it for one single variable, it's just going to be a matter of repeating the same thing using this two variable option as well. So let's just stick with one variable analysis for this tutorial. When it comes to the region, now you can see actually a bunch of different options for specifying the region. And what's quite interesting with this option is that you could either download a dataset for a specified point, or you could download the data for a specified region. Now I'm going to get started with this point for the time being. And if you click on this button, which is called Point Info, you can see that you have a number of different options to specify this point. You could either type in the exact longitude and latitude, or you could just type in the name and it would be able to locate it for you. Or the easiest, if you're just able to navigate using the base map, is going to be by using this marker and just by sliding it around like this. So that's exactly what I'm going to do. I'm just going to move this marker to somewhere over here. And that's going to be my point of interest for which I would like to download this data. And now let's get to the variable specifications. And similar to what we did before, our type is going to be climate and hydrology. And the dataset is going to be CHIRPS daily. And variable is going to be precipitation. I'm going to stick with this resolution. And when it comes to the statistic, well, it's not going to make much sense to pick a statistic in this, because now what we're going to do is we're going to specify the statistic over a region. And if it's a point location, then it's a point location. We're not going to aggregate anything. We're not going to take the mean of anything. It's just going to be a raw point data set. So in this case, it doesn't really matter what sort of statistic you are going to pick. Unlike in the previous case where our statistic was calculated over the day range. So that's the difference between the two. And the time period, I'm just going to stick with the custom period that I specified, which is from 1st of January of 2022 until the end of that year. And after that, click on Get Time Series. And now you can see that it basically gives us a time series like this. And it's a real time series with the raw data. If you just click right over here, you would actually be able to see the data itself. So for each day, you can see what the precipitation value happens to be. And the cool thing is that you can actually go ahead and download this dataset into something like a CSV file by clicking right over here. And after that, import it into a spreadsheet processing software. Now, I'm going to do that just in a second, but I'm going to head over to map again. And instead of selecting a point, let's just see what happens if we were to just go with this kind of a spatial selection using either a polygon, or you can use a custom polygon from a table asset. If you have an Esri shapefile, you could directly upload that Esri shapefile by selecting this option. For example, you can see that as soon as you select that, you'll get the instructions on how to upload a shapefile. So according to what it states right over here, choose a shapefile .shp or .zip of polygons, and after that it would be able to sort of locate that or locate your area of interest. And I'm not going to do that. Instead, what I'm going to do is I'm going to go with this polygon option, where it gives you the opportunity to sort of draw a polygon by yourself. And as you can see, all the instructions are given right over here. So I'm just going to use this very first instruction to sort of spatially highlight an area for which I'm interested in. And I'm going to pick this tool right over here, and holding my control button, I'm just going to zoom into one of these areas. After that, I'm just going to specify, well, this is going to be a very random specification of some region for which I would like to have my precipitation data. All right, let's just call that this is the region for which I would like to have my precipitation data. And now if you come back to this statistic, well, now selecting mean actually means something. So if I open up my QGIS file which I had previously, let's just say that if I were to pick the mean for some selected region like this, well, I'm just making use of this tool to sort of mark some area and show you guys. And if I were to select the mean, what Climate Engine is going to do is, for each particular day, it's going to take the average of all of these pixels and just give me one single value for each day. That means if I selected 365 days, it's going to basically repeat this process over and over again for each day. That means for the entire year, what I'm going to get as my precipitation value is not just one single pixel, but the average of all of these pixels that basically fall within my specified range like this. And instead of going with mean for the statistic, if you took max, then what it's going to do is it's going to basically pick the pixel value of the maximum value and then going to completely disregard the others. And a similar case happens for minimum as well. So I guess you guys got the idea how this spatial statistic actually works when it comes to downloading CHIRPS data from Climate Engine portal. Alright, so let's head back, and now what I'm going to do is, well, I think it makes sense to actually go with the mean, because in most applications I think it would make sense to take an average over this specified region. However, if you have a specific case where you have to do otherwise, then feel free to go for it. And all my remaining selections are going to be just as it is. And after that, click on Get Time Series. And as you can see over here, what we got right here as a time series is again just going to be 365 values if you head over to this data tab and check the values. Just because I selected an area doesn't mean that it's going to give me extra values. It's just going to give me one single value for each day that happens to be the average of all the pixels that lie within my specified area of interest. And let's just go ahead and download this dataset by heading over to Figure again, and we can download it as a CSV file just like this. And now if you open up this using a program like Microsoft Excel, you can basically see how the data looks right over here. So in this column right over here, you have the date, and over here you have the precipitation. So for example, if I were to just go ahead and get rid of this, and let me go ahead and insert another row and call this date, and this one as rainfall in millimeters. As we saw from Climate Engine itself, you would be able to draw things like graphs if you were to just plot this as a time series by heading over to Insert, and maybe you could just go with an option like this. But when it comes to plotting things like rainfall data, I think it would be suitable to use a bar chart like this, where you'd be able to clearly see a bar sticking out for each day, which recorded some sort of a precipitation. And also, if you're familiar with using things like pivot tables, you would be able to directly do assessments on this data set and get things like, for example, what was the total monthly rainfall according to this data set by heading over to Insert and Pivot Table. I'm just going to select existing worksheet, and I'm going to get my pivot table to display right around here. Click OK, and if you were to just select rainfall and months and have months over here and the sum of rainfall right over here, you would be able to see what the rainfall value for each month happened to be. So as you can see, it basically follows the trend as it should be. So right around here, you can see that the monthly rainfall basically increases. And again, it basically drops by the time we reach December. And right around January, February, it seems to be picking up again. And this is where you happen to get the highest rainfall according to this dataset. Now at the beginning of this tutorial, I told you guys that CHIRPS is actually a high resolution global precipitation dataset that combine satellite imagery with in-situ station data. So some form of a calibration has been done on this data using the ground records. But if I were to actually use this dataset for a serious study, I would always double check a downloaded rainfall dataset for a specific location from CHIRPS against some ground records which you might be able to obtain from your respective meteorological authorities or agencies, just to ensure that there aren't any significant biases in these datasets, which happens to be the case sometimes, because even though a correction has been done to a certain extent using some ground data, still there might be discrepancies between the actual ground records and the data. But once you manage to figure out those biases, then you would be able to sort of apply those corrections across the entire CHIRPS dataset, and that way you would be able to sort of do a one-time correction and confidently use this CHIRPS data for any purpose that you are intending to use them for. So guys, with that, we are going to wrap up this tutorial. I hope the concepts were clear for you guys, and if you do have any questions, add a comment down below. If you'd like to support the work that we're doing, you can hit that subscribe button and stay tuned for the upcoming tutorials. I'll see you guys again with another tutorial soon.